right, so this is on the back of the back of the first page. We just finished talking about how you can use the small intervals of average rate of change to make a prediction or estimate the rate of change at a point. Now what we're going to do is see how we can use average rates of change to determine if a function is linear, quadratic, or neither by looking at a table of values. So for any linear function, the average rate of change over any length, that's kind of important, any length interval, input value interval is constant. So I think you guys know that. The average rate of change of a line is always going to be the same. It's going to be a constant value everywhere. It's going to be whatever the slope is of that line. So that problem that you guys did on your worksheet, that was number 6, where all of those average rates of change were -1. Why do you think that happened? This is a line. So then that would mean that the slope at that one point is -1 because the slope everywhere is going to be the same. So that was just a little introduction to what we're going to do today. So on example 5, we are going to use the idea that the average rate of change is constant for a line to explain why this is not a line. Now, yesterday on all the little average rates of change, we did the fractions where we subtracted and subtracted. And I want you to do that in situations where you have to show your work and different things. But on these, I'm okay if we just look and see how much each part changed. So in the numerator of the average rate of change is how much the y changed, or how the y changed. So if our y value or output value changed from 4 to 7, how much did it change? 3 in the positive direction. So it increased by 3. So that 3 goes on the top of the fraction. And then how did the input value change? By 1. And so that's a slope of 3, or an average rate of change of 3. All right. And then on the next little section, how did my y value change? 3. What about the x value? 2. And then the last one is 3 again, and 4. So this is obviously not linear. If this was linear, we would have got the same thing for each one of those. And so to explain why, I would say that f of x is not a linear function because the average rate of change is not constant. So let's talk about how we can use average rates of change with quadratic functions. And so on example 6, we're going to consider the quadratic function g equals x squared. I want you to try to do as much as you can today without a calculator. And so we're going to fill in this table because I know we can square numbers without a calculator. So what is -3 squared? Good. -1 squared? 1, 9, 25. I feel like we can definitely do that faster than we could have just typed in the function in the calculator, so it's wise to not use it on this one. Okay, and so what we're going to do is find the average rate of change over each one of these intervals. I'm going to write my little fractions over to the side, but we're going to fill in the table with the average rates of change. All right, so if I'm just going to do how much it changed, the y changed from 9 to 1. So what kind of change is that? -8. All right, and then what about the x? +2. So that's going to make our average rate of change be -4. All right, the next one is a great one to do. How much did the y change? It's going to be 0. So anytime that that numerator is 0, as long as these two aren't also the same number, we can automatically say that that's going to be 0. All right, and then I went, this next time I go up by 8, and then these are 2 every time in this situation. And then last we go up by 16. All right, so obviously these are not the same. The average rates of change are not going to be constant on a quadratic function, but do you see any kind of relationship in these numbers? What is the pattern? What's happening? It's increasing by 4 each time. Yeah, so this is a linear pattern. So we could actually write an equation for the average rate of change, and that equation would be a line. This one is pretty easy because you're basically just gonna, it would just be, well, it's kind of hard. The slope of the line, it would just be a line. All right, so we said we noticed that the average rates of change display a linear pattern. Or you could say they're increasing by 4 or something like that. Now we are going to learn 3 different ways to be able to look at a table of values and determine if the function is linear or quadratic. So this is the first way, and they're all important just because of the way that things are worded in the multiple choice question. So when you guys go to do your assignment today, I worded it similarly to what you would see on the AP exam. And so you do need to know all 3 ways. You are going to like the last way the most. So that's why I'm saving it for last. So in this box, this is an important box because this is how it's going to be worded on the multiple choice questions. So for a quadratic function, the average rate, I can't talk, the average rates of change over, and these words are important, consecutive, equal length, input value, intervals, can be given by a linear function. Now for the linear function, like we're trying to decide, those input value intervals don't have to be the same. So like they can skip like this one did. But if it's quadratic, they do have to increase by the same amount each time, or we won't be able to make the determination. All right, so let's look at example 7. We have selected values of various functions in the tables. For each table, we're going to determine if the function could be linear, quadratic, or neither. So the first thing I'm going to do when I see a question like this is see if our input values are increasing or decreasing by the same amount. We have equal length intervals. Do we have equal length intervals on this one? Yeah. So I'm just going to make a note. So as long as that's true, we can answer quadratic. If it isn't true, then we can still answer linear and we can still answer neither, but we cannot answer quadratic. All right, so if I look at my change in y over my change in x, it looks like I'm going to get 1 over 1, 3 over 1, and 5 over 1. So definitely not linear, because those would all need to be the same. Is there a pattern here, a linear pattern, where you're increasing or decreasing by the same amount? Yeah, we're increasing by 2, right? So what does that mean this is going to be? Quadratic. Now there is one on your assignment, I think, where there's like a geometric pattern, or you're multiplying by something each time. That's not going to work for linear or quadratic. So for it to be quadratic, you need to be increasing or decreasing by the same amount. All right, let's look at the next one. So our input values, are they consecutive, equal length? No, because I increased by 1 and then 3 and then 5. So we're going to say not equal length. So because of that, we cannot determine if it's quadratic. We can still do the problem though, because it's possible it's linear, or if it's not linear, we'll just say neither. All right, let's see what happens. We're going to do the change in y over the change in x. So what do y'all think? Is this going to be linear or neither? Linear. You see that, right? I can't tell if you don't know, if you just don't want to talk to me. I can't tell. So if you do the average rates of change and you get the same, then it's 100% linear. All right, I'm going to have you do C on your own. It is okay if you get an average rate of change that it's a fraction. That's super common, so don't worry if you do. All right, so my input values do have equal length intervals. They're going up by 2 each time. So it can be any of the 3 answers. And so you should get 1, 1/2, and 0. Is that a linear pattern? What are you adding each time? 1/2, good. And so what type of equation is this? Quadratic. All right, so what questions do you guys have? All right, so you guys probably have time. You just have like 4 problems to do, 7 through 10 on the worksheet from the previous day. And while you were working, I put worksheets on desks. You weren't at your desk, so it's possible. Just make sure you have the right worksheet and the right stamp sheet.